Thanks. It's great to be here. Hopefully this is gonna pop up just fine. So what I want to do is play off what Simon talked about. So Simon talked about the role that diversity plays in terms of creating variation, and then selection allows you to choose the best one to lead to sort of robustness and resilience of systems. I want to give a slightly different spin, and I want to talk about how diverse collections, diverse ensembles, are actually what we need to solve really complex problems. And so what I'm going to do is I want to sort of link the idea of diversity to the concept of a collective intelligence, which somehow supersedes or even has sort of possibilities that the individuals that comprise the collective do not have within themselves. So here's sort of the core takeaway, and that is that cognitive diversity improves performance on complex tasks. So the best teams are going to be cognitively diverse. So very quickly, I just want to talk about what I mean by complexity, what I mean by diversity, and give two logics, one for prediction, one from problem solving. Do a brief detour into sort of how you think about sort of cognitive diversity and identity diversity, and then talk a little bit, within these organizations now, they're incredibly diverse, both disciplinarily, identity, culturally, all sorts of things. And so leadership has to take different forms. So it's not just a matter of having diverse people in the room, it has to do with managing and leading them in the right way. So to step back for just a second, I think, Simon, did such a nice job of thinking about how complex systems are. And we used to have this sort of Platonic idea that we could carve nature to its joints. And so one set of people could look at this, there'd be biologists, physicists, chemists, psychologists. We just break up the world into component, disciplines and solve things. We now know that the world is much more complex and we can't do that. Now, what do I mean by complexity? There's two notions of complexity, and I talk about these in my book, Diversity and Complexity. One is BOR, which is between ordered and random. And this is sort of a statistical view of things. So if I look at something like copper prices, which is the red line, that's neither ordered nor random. But if I look at copper production, which is the blue line, that's actually, a nice sort of simple growth curve. So when you look across economic data, biological data, any sort of ecological data, you'll see some things that are complex and some things that are not. Complex time series they're not random, but they're also not ordered. They're sort of in this in-between space. Another way to think of complexity, though, is what I call deep. It's something that would be difficult to evolve, engineer, explain, or predict, right? So the I is considered complex, so it's very difficult to think about how that evolved. Now, when we think about what the modern world is like, especially, I moved into a management school a couple of years ago because I just found the question so fascinating. It used to be businesses just thought about maximizing profits, right? But now we have 16 sustainable development goals, one of which is to coordinate, 17th is to coordinate on those 16. If you look even within any discipline, so this is a field called health technology assessment, it used to be that what they would do is they would look at something called QALYs, which are quality of life years, and then divide that by cost and say whether this particular health technology, whether it's a drug, a protocol, a surgical technique, was worthwhile. Now, as you can see, they've got this whole sort of value flower where there's scientific contributions, there's equity, there's the value of hope, there's spillovers to family. So we live in this world now where we're doing sort of multi-dimensional optimization, multi-criterion optimization, which is just much more complex. If you look at any one problem, so here's a map on obesity, and you can see all these different disciplines, from media, from social to psychological, and all these arrows are studies showing relationships between these different types of fields. So what this tells us is we can't carve nature at its joints, that we need to have interstitial tissue, we need to have overlap in what we study if we want to really make any progress on these complex problems. Now, what's the evidence? There's a ton of evidence on this, but I just want to show one recent paper by Dash and Wang. What you're seeing is you're going to move to the right is 2 authors, 3 authors, 4 authors, 5 authors. The top line is paper citations. Second is patent to paper citations. The bottom row is patent to patent citations. And what you're on each of these graphs, as you move from left to right, you're getting more diversity in the team. Now, as you move up in the lines, this is citations over 2 years, 5 years, and 10 years. So what you see from diverse teams is that diverse teams get a lot more citations, but it actually takes a while for that to materialize. So it typically takes 5 to 10 years. And that's because they're kind of doing deeper, more innovative stuff. Now, there's a bunch of different lenses you can put on this, number of citations, high impact papers, all sorts of things. It's the same story over and over and over again. the very best research comes from diverse teams. I should also add, so does the worst. And that's where management comes into play. So why? So why don't I just very quickly sort of just walk through two logics as to why. So let's first look at prediction. There's a very simple result you can write down called the diversity prediction theorem. So if we're predicting something, the crowd's error equals the average error minus the diversity. Now, I don't want to think of this as variance. I want to think of this as actually diverse predictions. Where does the diversity come in? It could come in representations. It could come in information. It could come in like the models people are using, or it could come in how we kind of combine the different ways of doing things. But there's all sorts of ways diversity can sort of enter in and how people or scientists look at problems. How big is that diversity bonus? It's always there. Well, if you look at economic forecasts, the crowd, this is 20,000 forecasts by professional economists over 40 years. The crowd of 30, 40 economists is 20% better than an average economist. Here's another way to look at this graph, that benchmark at an error of 1, an average economist. The best economist in this whole population was 10% better than an average economist. But if you choose any 4 random economists, you're actually 14% better than an average economist. So any 4 random economists are better than the best economist at predicting. And that's because predicting is complex in sort of both definitions of complexity. So the idea here, and this is where I think we've got to kind of hold 2 ideas in our head. We think of having a diverse portfolio from a risk mitigation standpoint, right? One stock goes up, one stock goes down, we get the average. And Andy Lowe can talk about this at length. But if we think about predicting, we actually get a bonus. The average prediction is actually more accurate than the average. So here's the top 4 predictors in that data set. They're 10%, 9%, 9%, and 8% better. If I hired the top 4 economists, I'd actually do 22% better. Now, what makes good groups good forecasters is the same thing that makes individuals good forecasters. So Phil Tetlock has done a lot of work on what he calls foxes and hedgehogs. Foxes are individuals who use many models, who think about things in lots of different ways. If you look at, this is a massive, massive prediction contest, largest one ever run by the US intelligence community. Phil had a team, I had a team, Phil's team won. Phil identified super forecasters who were 40% better than average people in the population. When he trained them, they got 10% better. But when you team them, you get another 10% lift. And when you aggregate them in the right way, taking into account diversity, you get another 35% lift. So what does this tell us? If I want to have good forecast, find good people, they're basically 40% better. But if I want to have really good forecasts, what I'm going to do is find diverse teams of good people, because they're another 40% better. Now, here's a super interesting thing to sort of think about. This is some work by Mark Stivers that just came out last year. If you look at humans and machines, so what you're seeing is the blue things are sort of machine only, the red ones are human only, and the green ones are hybrid. The left graph is accuracy. Hybrids are better. People were better at sort of classification than machines, but people plus machines were better than people. And the reason why is, if I get the right graph, the correlation, this is the green part, the correlation between people and machines was much lower, right? Much more negative than the correlation among people or the correlation within machines. So because people and machines think differently, hybrid groups are actually better than either people or machines. Very quickly, then problem solving. We can think of problem solving as like searching over a rugged landscape. You can construct a model where you have sort of diverse tools. And what you end up getting is that diverse groups of competent sort of algorithms will outperform the group of the best, and typically by a substantial margin. And the logic here is the following. We tend to think in terms of ability when putting together teams. So it's like an alpha group and a diverse group. But we should actually think in terms of toolboxes. And think of toolboxes, the alpha group may have all the same skills. So if I go visit the New York Fed, which I used to do on a regular basis pre-COVID, everybody in there's got the same tools. So this IL person is someone who maybe is a behavioral economist, or maybe a sociologist, or maybe an environmental scientist, or maybe a China expert. On their own, they wouldn't be maybe that good at managing the economy. But in the group, they add a lot of value. Another way to think about this is that if people see the world differently, they have a different adjacent possibles. They can think of different stuff. What are the implications of this is that if you've got a complex task and team members bring different solutions and produce synergies, there's no test that you can apply to individuals that produces near optimal teams. So if I'm trying to find the best team, there's no such thing as hiring the best people. That's just logically inconsistent. And Luohan and I have a recent paper that's under submission that generalizes this to a whole class of problems. So generally, no sort of test exists. 2 last points. Identity diversity, cognitive diversity, how does this play out? And how does leadership and management come into play? So Catherine Phillips was my co-author on a book on this. She says, here's the really interesting thing. When you look, identity diverse groups, socially diverse groups are actually the very best groups, right? So the cognitive diversity stuff makes sense, but why is it that identity diversity groups are? So when you think of identity diversity, we think of things like gender, race, age, this sort of stuff, right? Now there's reasoning effects. We tend to arrive at our opinions sort of intuitively and justify them. And so what happens is our lived experiences affect how we think about things. And so our identity diversity translates into cognitive diversity, which then we have a lot of sort of logic and math to explain why that gives us better outcomes. But it's tricky. I think 15, 20 years ago, people used to think we could pull out one part of our identities and map that into cognitive differences. Now the sort of state of the art is to say, no, actually we're bundled. Some people call this intersectionality, but the full bundle of people's characteristics affects the movies we watch, the books we read, the classes we take, the things we study. So who we are affects what we know, not for some essential reasons, primarily because of sort of cultural and social reasons. Second really interesting thing that's kind of understudied, there's some nice work by Sandy Pentland at MIT on this, is that there's group effects. People think differently and harder when you're in an identity diverse group. Last thing, identity drives purpose. So I sometimes call this the Mary Oliver question. What do you plan to do with your one wild and precious life? This is driven by who you are. Okay, last point, and I'll be done, 30 seconds. It really does matter how a group is led, what the organizational culture is like, if you want the benefits from diversity to materialize, to actually produce collective intelligence. So again, if you look across all these research papers, all these patents, best groups are diverse, worst groups are diverse. You look at 30 years of research, hundreds and hundreds of studies on groups and teams and organizations, best groups are diverse, worst groups are diverse. So management really matters. Within this kind of business case, then there's at the core a human case. How do you motivate people? How do you help people grow? How do you make these teams function well? Let me just give sort of two almost identical views of this. You can think of this almost like a narrow corridor sort of argument. You have to care about people and you have to challenge them. Or as Amy Edmondson says, people have to feel safe and they have to feel motivated. If you care about people, you don't challenge them, you're in this ruinous empathy box, according to Jill. But what you want to be is in this kind of radical candor box or this learning zone box. So people have to be challenged. This is almost like the selection part. I'm going to pull this back to Fisher's fundamental theorem. This is the selection stuff. You need diverse ideas, but you've got to, kind of hold them up to the light. If people don't feel safe, if they don't feel cared for, you don't get the diversity from which you can select. And so one of the things that we're sort of coming back to from organizational theory, when you look at what makes diverse teams work really well, it's back to Fisher's fundamental theorem. You need the diversity to be materialized. You need people to feel safe, share, and bring it out. Then it has to be challenged and selected on. And if you do that, you end up getting this collective intelligence. So takeaways, once something's complex, you need diverse ability. You need cognitive diversity, different understandings, different representations, different models. Cognitive diversity and identity diversity are related in really interesting, deep ways that we don't fully understand. And to get those benefits, what you need is inclusive leadership. And hopefully Martin can build off that because he's sort of an expert in that area.